the recordings with everybody. So good morning again. My name is Nancy Gaucher, and I'm a knowledge mobilization specialist at the University of Waterloo's Water Institute. I'm going to be your host for the webinar this morning. Today's webinar is focusing on farming practices for undulating and sloping loams. Like I just mentioned, we're recording the webinar, and once we have it transcribed for accessibility purposes, we'll share this. So some quick reminders. This is set up as a Zoom meeting, so please be sure to keep your audio off and your video off and your audio muted. And we're going to begin with Merrin's presentation, followed by a Q&A and a final closing poll. So please type any questions that you have throughout the webinar into the chat box, and we'll get through as many of those as we can. I think I'll close the poll at this point, but I'll quickly share some of the results. In terms of where people are from, we've got good representation from Ontario and a bit from Ohio as well. We've got a few cash crop farmers, some certified crop advisors, a bunch of Conservation Authority staff and researchers. So that's a really good mix of people joining us. For those that are farming, we have farmers trying cover crops, conservation tillage, and no-till. Main motivation for using BMPs, a good kind of cross-section between erosion, soil health, and water quality, as well as some yield increase. And most people who are farming seem to be willing to try newer BMPs, which is great. And it seems like choice 2 is beating out choice 1. So thanks so much for that. So I want to start by acknowledging that we're participating today from traditional territories of First Peoples across Canada. I'm in Kitchener-Waterloo, and so I acknowledge that I'm on the Haldimand Track, and this is land that was promised to the neutral Anishinaabe and Haudenosaunee peoples. So today you're going to hear from Professor Merrin Macrae. Merrin is a professor in the Department of Geography and Environmental Management at the University of Waterloo. Her research interests center around nutrient dynamics and water quality in agricultural landscapes and wetlands. Dr. Macrae studies water quality at both watershed and field scales with an emphasis on assisted drainage. A key aspect of her work involves understanding the winter and snowmelt periods and the efficacy of beneficial management practices during these critical times. With that, I will stop sharing my screen and allow Merrin to take over for us.
Great. Thank you very much. It's really a pleasure to be here. So Nancy, this is just a quick check that you're seeing what you should be seeing.
Yeah.
Excellent. Okay, so thank you. Yes, it's really a pleasure to be here. So I'm going to be speaking about optimizing BMPs depending on where you farm, and essentially we're focusing on undulating or sloping loam soil. So really outside of those level or flat heavy clays that tend to be found around in the southwestern end and around the lake. And we're sort of going out towards the outskirts, certainly into things like certainly on the Ontario side, into say the Upper Thames and the Upper Grand as well. So let's just get started with a little bit of context or background. So we know that Lake Erie has a long history of water quality impairment. We know that things really improved a lot in water quality during, say, the 1980s and the 1990s, and that was really driven by improvements in wastewater treatment and reducing those point sources. The problem is that the lake has really undergone a period of reeutrophication over the last, say, 20 years. And today we know that most of the phosphorus that's entering the lake is really coming from non-point sources are really the dominant source of phosphorus to the lake at this time. And so we've been applying BMPs throughout the watershed and doing so for a very long time, but we're still seeing this emergence of these harmful blooms. So why is this? Well, some of it can be climate. We know that the climate is intensifying. Some of it is legacy phosphorus, so phosphorus that's still out in the landscape. Some of it might be that we're not doing enough in terms of BMP adoption, but it also might be that we're using BMPs, but maybe not the right BMPs in the right places. And I'd like to take a look at that today. So often when we think about we used to call them best management practices. You might hear us talk about beneficial management practices. So we either way, it's BMPs or conservation practices. But ultimately, when we start to think about the things that we can do, there's a lot of options that are available to us. And the fact is that some of these things are going to be more effective than others. Some of them have been shown to improve conditions under some conditions, but be less effective under other conditions, or they can even have unintended consequences or trade-offs. So that's where they work really well in one situation, and then we applied them and found, oops, this actually has the opposite effect. So we're trying to avoid those unintended consequences and the trade-offs. So winter conditions in particular are really poorly understood. And the information that we do have from the winter environment, this information is often from a lot more severe climates, like say the Canadian prairies or the Nordic regions. And so when we try to extrapolate those winter conditions to our own region, it may not necessarily apply, and it can lead to a lot of confusion. So in the past, I have been asked I've been asked at presentations or by farmers, conservation or CCAs or other specialists, what should we do to reduce phosphorus losses from farm fields? And collectively, often we say our initial response is there is no silver bullet. And the other thing is people are often told, do as many things as you can because they work synergistically. So we know that stacking BMPs is useful. If each thing that you do does a little bit, stacking them on top of each other can lead to a lot. The problem is that there's a cost to BMP application, and simply stacking more and more on top of each other, knowing that some of them won't work, isn't always fair as well, because we have to remember that these are real families. These are people who are being asked to take risks, change their farming practices. Every little change that we ask people to make can cost them money, either direct costs or opportunity costs. And so if we just say, do everything, even though we know a whole bunch of the ones that we're telling you to do aren't going to work, that's going to damage trust between farmers and managers or scientists. And it can also damage trust if we tell people to do one thing and then later on say, oops, no, we were wrong, do something else. So we really need to make sure that we're very strategic and fair about what we ask people to do. And if we can get people to do, say, 3 things on their farm, it is really important that those 3 things are the best things that are going to work for them, the most effective things. And I think that can differ depending on where you are. So as an overview, the things I'm going to talk about in terms of structuring this presentation, I'm going to talk about how climate and landscape in the Lake Erie watershed differ. Then we're going to talk about how these differences impact phosphorus losses. How might BMPs differ regionally among these regions in terms of their efficacy? And then how can we use this information moving forward? And if you're interested in looking at this in a little bit more detail, this is all really emerging from a recent publication that I've listed on the bottom of the screen that you can see in front of you. One size does not fit all, towards regional conservation practice guidance to reduce phosphorus loss risk in the Lake Erie watershed. And that was in Journal of Environmental Quality in this year, and it's open access. So you can definitely access that online and read the paper for yourself. So let's start with how things might differ throughout the Lake Erie watershed. So when we think about variability across regions, we might think about how things differ between, say, the Great Lakes region and the Red River Basin. But we don't necessarily think about the subtle differences that exist within our own watershed that might be really important to water quality and BMP efficacy. So certainly from a precipitation perspective, we're a humid region in the grand scheme of things, but we definitely see areas with higher and lower precipitation in the watershed. But what's really important to note is that there's not just differences in the amounts of precipitation, there's also differences in the form of that precipitation. And a greater proportion of our precipitation, and certainly we basically, once we start to get into some of these cooler areas, we start to see more snow than they might see in the warmer southwestern end. So you can see that it's cooler as we move to the northeast and warmer annually as we move to the southwest. We also see that because they're warmer, they have a longer growing season up towards the northeast. And on both sides, we have a smaller or a shorter growing season. But another thing that's really important to note is the duration of snow cover. And so we're going to see snow throughout the entire watershed, but we have snow on the ground for longer once we get into these regions that are showing up as blue. And then once we get down into the southwestern end, we don't have snow for as long. Some of that reflects the shorter growing season or the longer growing season in the southwest, but some of it is because it's warmer in general and you're more likely to get freeze thaw, where you get snow and then you have a thaw and a complete loss of the snowpack. Here we can get thaws, but we tend to get more of a persistent snow. So snow will go on the ground and it'll stay for longer. So we also see differences in the landscape. So if you notice the elevation in the top right, so you can see that if we look towards the areas that are just right around the lake, these are very, very low elevation and they tend to be quite flat. They also tend to be very, very fine soils, fine textured soils. So that would be those heavy clays because they're from the past glacial activity, these clay sediments were laid down. But once we move to the outskirts, we start to see higher elevation, we see more sloping ground, and we start to see these more coarser textured soils. And so these are going to behave differently than the very flat or level or near level clays that you might see in really around the lake itself. So when we look at the land management throughout the watershed, the yellow is corn and soy, and boy, can we ever see the dominance of corn and soy. But we do start to, especially on the Ontario side, and more so as we start to move into that undulating or sloping ground, we really start to see more winter wheat getting into the rotation. It's interesting, like that on the American sides, when we start to get, certainly and also in these very cooler and sloping areas, we do start to see more of the green, which is the pasture and forage. We do start to see that. Another feature that's really important is looking at the density of tile drainage. So as we start to move down towards the southwestern end of Lake Erie, there's an incredibly dense amount of tile drainage on farmed fields, and we don't see the same density elsewhere as you move away from that zone. So what we did is we put all of this together and we looked at whether or not these differences, because we often talk about sort of these northeastern areas and the southwest, and we talk about the fact that these landscapes seem to differ, and they differ in a lot of different ways. So when we put it all together, what we found is that it really did come to that we had some of these what we call end points or end members. So we had these blue areas in the northeast. So that was not just on the Ontario side, but also the American side. So these were these undulating coarse soils that tended to be cooler cooler, more significant winters. Then we had the Southwest, which was very, very flat, very, very warm. And then we had these areas in the middle that I call transitional zones. We have the transition in the north and the transition in the south. And they're transitions because certainly from a climate perspective, they're transitional between the northeast and the southwest. But the landscape I find differs really, again, if you think about sort of what's around the lake, where you're talking about those flat soils, clay soils versus more sloping ground towards the periphery. So we know we need to divide these landscapes up. And so a first approximation would be to simply do what we've done here. Just did a quick tracing tool, but this is definitely something that's up for discussion and should be done in future. So we know it's not a perfect split at this point, but it's just a first approximation. So the next thing I'd like to talk about is how do these differences impact phosphorus losses? So when we think about how phosphorus is leaving fields at the edge of the field, we have known about surface runoff or overland flow for a very, very long time. So the fact is, we know that water washes on the soil surface and it's either going to erode sediment, so soil, which of course has phosphorus attached to it, so we call that particulate phosphorus. So we know that that can be lost through erosion. And the other thing is that we can have dissolved phosphorus. So the stuff that you can't see, but if you have high concentrations in your surface soils, which they typically are, that can be dissolved and lost in surface runoff as well at the edge of the field. So we've known about that. So there were a lot of conservation practices that were put in place that would encourage infiltration, reduce erosion of the surface soils, keep those soils on the fields. And this was the way we were promoting conservation. And we really didn't worry about anything that went under the ground because we know that soils tend to like to filter out that phosphorus. The problem is that in areas with assisted tile or artificial drainage, so tile drainage, this is a pathway that was less understood. And so the fact is that we thought, well, it's underground, the soil's a filter, don't worry about it. But we actually now know that tiles can play a really, really important role in the phosphorus story because phosphorus can actually bypass the filtering of the soil and then be discharged directly into our waterways and tributaries. And so this is a really big problem. So we need to understand this. So what we did is track edge of field losses over about a 5-year period. And we did this near Essex in conjunction with the Essex Region Conservation Authority. And then we also did it at some other sites in the Lake Erie and Huron watersheds. So we had sites in Ilderton, Lonsborough, and even in Eastern Ontario near Baynesville for a period of time. And we wanted to know how much phosphorus and water leave in the surface and in tiles. And we found that the answer to this really depends on where you live. So the first question thing I'd like to talk about is the form of phosphorus that leaves the fields. So we know that so there's a lot of discussion about dissolved or particulate phosphorus. And so dissolved phosphorus, or what we like to call dissolved reactive phosphorus, is what is the bioavailable form. That is the one that plants and algae and bacteria can use, and that's what's really fueling the blooms. So that one is obviously of concern. It's important to realize that of the phosphorus that's lost at the edge of the field, total phosphorus, which is the combination of dissolved and particulate phosphorus is more of the phosphorus that leaves at the edge of the field is as particulate. And this is particularly the case in the undulating loams. In the flat clays, it's still mostly particulate, but it's a little bit more even. It's more of a 60-40 split. Okay, so then when we start to think about where the water is leaving at the edge of the field and how much phosphorus is tied to that, again, it depends on where you live. So we found that across all of our sites and over multiple years, about 80% of the water left in tiles, so tiles are shown in blue, 80% of the water left in tile drainage, maybe 20% left in surface runoff. And this didn't matter whether you were in the loams or in the clay. So this would be, of course, the undulating loams are this northeastern end, and the flat clay is our Essex site, which is really basically this southwestern idea. And so when we looked at the dissolved reactive phosphorus, we noticed that in the clays, it was pretty much the same thing. 80% phosphorus in the of DRP, or dissolved reactive P, lost in the tiles, and only 20% left in the surface. But once you got into the undulating loams, it was completely different. This little 20% of the flow accounted for, on average, about 60% of the dissolved reactive phosphorus, and in some years, as much as 80%. So that little bit of runoff is where most of the dissolved reactive P was leaving. For total P, it tended to be a little bit more evenly split. So what does this tell us about the situation here? We cannot ignore tile drainage. They are an important source of phosphorus, but they're an important pathway for phosphorus, but they're an important pathway because so much water moves through them. The fact is that your surface runoff is a much more efficient pathway for phosphorus losses. So we want to make sure that whatever we do, it's not at the expense of, in terms of you just don't want to do anything that's going to elevate losses in surface runoff, because that still is the major issue in this region. You need to manage in both the surface and in the subsurface, but really that erosion of particulates is really an important part of the phosphorus story when you get into these northeastern ends, into that sort of anywhere where you're starting to see that sloping or undulating ground. So probably up in here as well. So in the clay soils, I won't emphasize that here, but like I said, the dissolved reactive P is about even. We see a little bit more surface total phosphorus in the surface runoff in the flat clays, and that's because we can definitely still have a lot of erosion, particularly in the non-growing season, and that can be both water and wind erosion. Now, what about when is most of this phosphorus loss happening? So what often happens is in these undulating loams, we tend to have wet periods followed by dry periods, wet periods, dry periods. So throughout the non-growing season, we will see a lot of activity between October and April, and probably by about June, your tile drainage, they go to sleep and they don't really wake up again until October, unless you get a lot of rain. And by a lot of rain, I'm talking about, inches of rain before you're going to see any sort of a response in the tiles. And even then, it might not be much of one. And surface runoff, although you can see it happening in the summer, so I did get a July photograph following an absolutely massive event, it's really uncommon. And most of the time, your surface runoff, which is what I'm showing in blue on these graphs, is actually associated with the non-growing season. So you can have a lot of fall rains, or you can really especially have it associated with snowmelt during those midwinter thaws. So you can see we have these wet, dry periods, wet periods, dry periods. The clays are a little bit of a different story. The fact is it can be a little bit more chronic. And so we can tend to see these big storms in the summertime that can connect the landscape. So we can definitely, it's not quite as exaggerated in these flat clays as it is in the undulating loams. But it does tell us, we know that most of our loss is happening during the non-growing season associated with peak flow conditions, meaning it's both tile and surface runoff, and that's happening especially with snowmelt. So it means that what we do in the non-growing season, how fields are left over the winter, is really, really important. So how might BMPs differ between our regions that we've shown? So some BMPs are going to work everywhere, irrespective of climate or landscape. And some we have to use with a little bit more caution, and we might have to use specific practices that are tied to specific landscapes. So we know, we've all heard of the 4R's nutrient stewardship, which I think is fantastic. So this is the right source, right rate, right time, and right place. So as a concept, I think this is really great, but we might find that the specific practices that are right might vary across regions. So let's talk about some examples of this. So starting with applying phosphorus at the right rate. So part of this is your application, but part of it is also what levels your soil fertility or soil test P might be at. So what we actually have are some graphs. These are from the American side, and this is from Ontario. And what we're seeing is soil test P. So this is Malic 3 on the x-axis in the Ohio examples. And this is Olson, or the bicarb, in the Ontario samples. But the same idea is there, both with, with phosphorus losses or concentrations or loads. And in this case, it's both concentrations of TP so total phosphorus, which is particulate, and dissolved reactive P. And what we see is that as your soil fertility increases with phosphorus, your soil P increases, your runoff concentrations increase. And we know this is true both in surface runoff and in tile drainage. So we know that reducing your soil P can decrease your phosphorus loss in both the surface and the subsurface. And in really elevated soils in Manitoba, actually, a recent paper by Jian Liu and others found that if they reduced that soil P by in these elevated sites, they were able to see a reduction in their runoff phosphorus losses without seeing a yield response. So this is really good news, but we have to remember that the reduction of that soil P, it's going to take time. So we can't rely on that alone. Also, again, the study by Liu was in more elevated soils. And in a lot of cases, people are really at the lower end of these curves and they don't have as much wiggle room. And we have to make sure that we're getting, that we are at agronomic levels. So you definitely want to, I know sometimes people like to apply a little bit extra as insurance. Don't do this. If you can really maintain your fertility at agronomic levels and only apply what you need, this is really going to make a big difference. OMAFRA has tools, your certified crop advisors can give guidelines, but essentially only applying what we need for the crops that we're growing based on the soil fertility that we have is really going to make a lot of difference. So in order to achieve that, we also need to make sure that we're testing our soils on a regular basis. Another thing that seems to be really helpful everywhere is not leaving phosphorus on the surface. We found that if we placed phosphorus and nitrogen in bands in the subsurface, phosphorus losses in leachate, so this was basically what would be leached through the soil profile and ultimately go into tile drains, we found that this decreased by about 60% for both nitrogen and phosphorus. But that was when we both broadcast and subsurface applied at the same rate, because we wanted to just look at pathways. So we applied them at the same rate. In reality, if you were banding or subsurface placing your nutrients, you would not apply them at the same rate. So a study by Doug Smith in the United States, Doug Smith and others, they estimated a difference of more like 90%. So subsurface phosphorus application can make a huge difference. So what about if you can't apply in the subsurface, like if you have to broadcast your fertilizer or your manure? So we have limited data on this, but it looks like incorporating manure can also reduce reduce losses a little bit in tile drainage. But then you have to balance this out with concerns with tillage, which can increase phosphorus losses in surface runoff, which I'm going to get to the tillage argument in a minute, so I'll leave that there. But I think that ultimately, the more people we can get to use subsurface placement, the better. Now, does this differ between the Northeast and the Southwest? I think subsurface placement is something that's going to be really good everywhere, but in the southwestern end where tiles are the primary pathway, subsurface placement can be really helpful because it basically disconnects that phosphorus. So here's a graphic. So this is, imagine this is the tile drain under here. And when we broadcast at the surface, that water is going to move through, the water and the phosphorus is going to move through preferential flow pathways. And you can see an example of this here. So we sprinkled blue dye on the surface and it went down into these preferential flow paths. If you only apply it in a band in the subsurface, the odds of it connecting with a preferential flow path, especially one that leads to a directly to a tile, the odds are pretty small, and you're more likely that they're going to bypass that band and that fertilizer is going to be where the plant needs it without being lost in the subsurface. So, and we also think that even in surface runoff, because you've gotten it underground, it's less interaction with the surface runoff. So we think it can reduce things both in the surface and in the subsurface. But in terms of differences, like I said, between the northeast and the southwestern end, I think in the southwestern end, if actually, I'm getting ahead of myself. Never mind. I'm going to move back to timing. Sorry. In terms of timing, obviously, we know that we should not apply to frozen ground. And in the northeastern end, getting that phosphorus on the fields earlier in the season is better. If you grow corn and soy, getting wheat into the rotation gives you a window to apply your phosphorus earlier. And a lot of the people that we worked with who were a corn, soy, winter wheat rotation, the bulk of their phosphorus application was done following wheat. And this is especially useful if you can't get enough phosphorus on at the time of seeding, or if you need to get your primary P application on at that point, or if you broadcast and you till at that time. Getting wheat into the rotation helps with that. In the southwestern end, the fall window is a lot longer because they have a longer growing season and their falls are a little drier than ours and milder, but you still want to avoid winter. I know that some people will go onto fields and apply in winter to avoid compaction, but applying phosphorus on, especially manure, applying manure on frozen ground is absolutely the worst thing that you can possibly do because it's just going to leave. It's just going to flow right off of the fields into the waterways. So we've heard that in tile drain landscapes, no-till can increase phosphorus loss in tile drainage because of both increased phosphorus stratification and preferential flow. So by P stratification, we mean that it becomes quite concentrated at the soil surface. And because you don't till, these preferential flow paths are nice and established. And so that high P will move directly into those preferential flow paths. And so this, of course, was really, really upsetting to farmers who had gone to no-till to keep their soil on the fields and reduce erosion and phosphorus loss and surface runoff. And they were really seeing the benefits of no-till and were now questioning whether or not they should be tilling up their soils. In fact, this is how I really got started doing edge of field research in Ontario. I'd always worked at the watershed scale before, and the answers farmers wanted to know if no-till was in fact increasing phosphorus losses in tile drainage. But what's interesting is a lot of these guys were in sloping, undulating soils, the ones that I was working with. So tillage has become a really hot topic everywhere, but particularly in the Lake Erie watershed. And so, as I said, in the southwestern end, no-till has been linked to elevated phosphorus losses in tile drainage, so an unintended consequence. But it's important to note that tillage is not necessarily doing this, but rather it's the surface application of phosphorus on top of the no-tills. So, as you saw in my earlier slide, if you can apply in a band, then you can basically eliminate, or not necessarily eliminate, but reduce those issues and enjoy the benefits of no-till. But we had a lot of people, based on the information coming out of the Southwest, had a lot of the people in these sloping landscapes asking if they should think about tilling up their soils, because they've been told that it mixes in the phosphorus and it breaks up those pores, those macropores or preferential flow paths that goes into tile drains. Well, I think it's important to notice that preferential flow paths between those loamy soils and these clay soils, they behave a little bit differently, and there is more opportunity for buffering to happen in the soil profile when you move into these loamy systems. But should people till or not till? Let's go back to our perspectives on the complete story. So when we look at our undulating ground in this northeastern end, remember, most of the water goes below the surface and only a small amount is above the surface. You might think, oh, I don't get any surface runoff. I only see it a couple of days a year. That's correct. It may only be a couple of days a year, but that couple of days a year is where more than half of the phosphorus is going to be lost, or at least half. So it is really important, that little bit of time. But remember, most of the phosphorus, or at least half, and more than half of the dissolved P are lost in that surface runoff. And we know that most of that phosphorus is in a particulate form. So if we had people in these northeastern undulating landscapes move to tillage, they would probably increase their edge of field losses. And so in order to protect what was going through the tiles, they would increase what was being lost in their surface runoff. Tiles are not really the issue. Surface runoff is. So the bottom line is that the more people we can get to no-till, and if you can't go to no-till, at least go to a conservation till or a rotational till. It's going to make a big difference at getting, or at helping that phosphorus stay on the soils. Now in Essex, so our Essex site, which is our southwestern level sites, should they till or not till? We still recommend no till, because again, you can still have erosion in that surface. And so if you no till, you can enjoy the benefits of that no till. But in order to decrease the risk of P loss going into the tile drains, you want to accompany that tillage with subsurface banding. If you have to leave that phosphorus on the surface, then what you want to do is maybe have a shallow or low disturbance incorporation rather than leaving it on the surface in the southwestern end. So what about cover crops? Cover crops are something that is another area that's been really discussed. These offer a lot of benefits, including a reduction in particulate phosphorus losses at the surface. And so the photographs on the screen show sediment in surface runoff in a flume in fields with and without cover crops. And we can see this person's boots in a field with and in a field without cover crops. So we know that they offer a lot of benefits in terms of soil health and organic matter, infiltration, water holding capacity, and we know that they can reduce phosphorus losses in surface runoff from an erosion standpoint. The problem is that some winter studies have talked about a risk of phosphorus loss following freezing in winter. Let's talk about where those findings have come from, because this is where I talked about other studies where we've drawn their conclusion and applied them to our own. So if we contrast the Canadian prairies with the milder Great Lakes region, remember, we have the moderating influence of those lakes that help our climate stay a little bit more moderate. We can definitely have cold temperatures, although not as cold as they see in the prairies. So the red is showing you your air temperatures. But what's important is look at the amount of, we get definitely more rain, but also a lot more snow on the ground. And so what this means is that because we get more snow, we get a bigger insulating effect than they do in the prairies that are very flat and they get a lot of wind that blows that snow around. And so because of that, they tend to get it easily 4 feet of frozen ground in a lot of winters, whereas we may not get much soil frost at all. And if we do, it's quite shallow. So this means that our crops are not exposed to the same winter temperatures that they are in the prairies. So it's not uncommon for us to see temperatures that are maybe -4 under the snowpack. So the roots and the cover crops might get exposed to -4 or even closer to 0 temperatures, unless we get a complete loss of the snowpack. And then in that case, they're going to get exposed to the same temperatures that the air is. So we did some experiments, we did some experiments where we exposed cover crops to a very cold freeze-thaw cycle and a more moderate freeze-thaw cycle. And we found that there was definitely a difference. If you had the more modest frosts that are common in this region, they didn't really lose very much. They were able to withstand it. If, on the other hand, you exposed them to a very heavy frost, they lost something, and this was particularly true with your tender frost-killed crops, so oats or oilseed radish, and the hardier crops didn't fare as badly. We also found that if you terminated your cover crops, they lost everything. So the fact is that if you're in a region that tends to really get plunging temperatures and you don't have any snow to speak of to insulate, then you maybe want to optimize what you plant in order to reduce that risk of winter pea losses. So the other thing that's important is moisture contact. So sometimes you have fields that are prone to surface ponding for extended periods, particularly around snowmelt. In these zones of the fields, that's where the crops can really release a lot of phosphorus. Whereas in these upper slope areas, it doesn't tend to release as much because it doesn't have as much contact. So if you tend to have fields or section of fields that pond a lot, maybe think about not putting as much in the way of cover crops in these very flat areas, but maybe keep them in areas that are prone to erosion that don't see as much surface ponding. So what does this mean for our different regions? So if you think about the bottom 2 pictures are from our southwestern end, so they can look like this or they can look like this. And the same is true. This is Eilderton and this is Lonsborough. So these are more in these undulating systems. And this is actually in my backyard just outside of Waterloo. So the fact is they can both be snow covered and they can both be snow free. But these areas in the southwestern end are going to look like this for a greater proportion of the time than these. And these areas in the northeast are going to look like this for a greater proportion of the time. So the fact is, even though the northeast, those undulating landscapes in the northeast are colder, because they have so much snow, the cover crops are less likely to experience massive frosts because we have that insulating blanket. Now, also remember that erosion of particulate phosphorus in surface runoff is your primary phosphorus loss pathway, and cover crops can help with that. So the fact is, in these undulating landscapes in the northeast, and even in the northwest, in the undulating landscapes, and on the American side, the fact is cover crops are going to be a great idea. With one caveat, watch out if you really see a lot of surface ponding in some of those low-lying areas of your fields. On the other hand, in the southwestern end, I also think that cover crops are a good idea. But although the Southwest is warmer in general, it's more prone to freeze thaw and winter phosphorus loss from cover crops because of that complete loss of the snowpack and those plunging temperatures. But what we can do is we can simply think about which species that we're using and manage and optimize the cover crop species that we plant to reduce those winter losses. I think that cover crops are a net benefit. The other thing to remember is that in the southwestern end, tiles are where most of your phosphorus is being lost anyway, not as much in the surface runoff. So I think at the end of the day, cover crops are a net benefit, but if you want to reduce that risk of winter losses, manage your species carefully in the southwestern end. But we definitely need some paired field studies to validate this. Some of the material that I've been presenting today is based on our own field studies, and some of it is extrapolating from other sites, not necessarily our own field sites. So really starting to wrap things up. Regions throughout the Lake Erie watershed have different climates and landscapes, and this is going to affect phosphorus loss throughout the watershed. And so this means that the conservation practices that we use may also differ throughout that Lake Erie watershed. And so you want to think about different phosphorus management zones. And so we're not specifically saying this is exactly what somebody should be doing on a given field. We're trying to sort of promote general principles where practices will be more or less effective. So to summarize, in our undulating loams, you want to keep that soil test P at agronomic levels. And this is going to apply everywhere, not just in the undulating loams. We want to use soil testing, follow OMAFRA recommendations. Also, don't apply manure on the same fields repeatedly, and don't apply more fertilizer than you need. With regards to no-till, no-till is really the best thing that we can do in undulating loams. And if you can't be truly no-till, going rotationally and using a shallow conservation till is really optimal to doing annual tillage. Remember that most phosphorus is lost as particulate P in sediment or erosion of those soils off of those fields. Also, do consider erosion control structures. If you do till rotationally, getting winter wheat into the rotation helps this happen earlier, which gives your fields a little bit more time to recover before that wet season starts to come into play. Cover crops, snow insulates the plants, so the risk of phosphorus loss following frost is pretty low. I do think that cover crops are a great idea, and even those that frost kill, if you're concerned about managing them in the spring, they're okay in these undulating loams. We actually found in the undulating loams that even when cover crops did reduce phosphorus, it actually ended up being held by the soil, and it didn't translate to edge of field losses because most of that phosphorus that was stripped from the plants just went into the soil and was held by the soil. And so remember, those plants reduce erosion and particulate P losses. Subsurface placement of phosphorus, and also thinking about timing. I really do think subsurface placement at the time of seeding is best. So thinking about corn and wheat, you really want to, if we can get more people doing that, the better. You obviously never want to apply in winter on frozen ground, and you also want to avoid applying in late fall if you can. The earlier you can get that phosphorus on, the better. The Play-Doh tool, which is a really great way where you can see the risks associated with some of these things. Finally, how can we use this information? So we really recommended 5 steps for where we needed to go next. And so the first was to refine phosphorus management regions. So this is a nice graphic that they put together for CSA News based on our paper in Journal of Environmental Quality. So we want to refine these phosphorus management regions. Like I said, we really had the Northeast and we had the Southwest, and we had these transitional areas in between them. And so as a first approximation, we've just kind of cut this down the middle based on landscape. But the fact is that we need a further exploration of how we might specifically break this down. And do we need 2 or 3 or more phosphorus management regions? So that's up for discussion, and something that I'm absolutely happy to talk with some of you about at the end of this presentation if you're interested in. It's definitely up for discussion. So the next is to develop region-specific guidance through improved conservation practice catalogs or fertilizer recommendations. So that's where we want to start to use these phosphorus management zones and say, here's what we think are the best things that you can do based on where you live. And then we need to, once we develop these catalogs and recommendations, we need to have some, we need to match this up with some field trials that are linked to water quality monitoring. Like I said, some of this is direct studies, but some of it is we're inferring what we think is the case based on what we know about processes either in this watershed or around even in North America and elsewhere. So we do need to verify and validate these things. We need to communicate these results, our confidence in these results with producers, and then we need to make sure that we have an adaptive management framework so that we can go back and forth and optimize these. We also want to expand these phosphorus management regions for things like nitrogen. It's not all about phosphorus. What I've spoken about today is about phosphorus, but there's a lot of other reasons that people make decisions based on practices that they do on their farms. And with that, I thank you very much for listening, and I look forward to any questions that you might have. Thank you very much.
Great, thank you so much, Merrin. That was really excellent. We're moving into the Q&A portion, so I encourage anyone to ask their questions. Ideally, you can post them in the chat box, but if you want to articulate it orally, let me know. And in the meantime, I will just once again remind folks that this webinar is being recorded, and we will be posting it on our YouTube channel. I'll send a link out to everybody who's attended, and therefore you'll have access to that. It might take a few weeks because we need to have it transcribed for accessibility purposes, but you can keep an eye on your email for those links. Any questions for Merrin? If you don't have questions, I have questions for the audience. I'm wondering if anyone has any ideas on how we can promote this message, get it out further, make sure people are hearing about it. Merrin, one of the questions that I have in a closing poll, which I'll post shortly, is for people to get in touch with us if they're interested in working with us on the next steps of this research. So I know that you mentioned that one of the questions we have is to refine those transition zones. Can you speak to how you might think we would work with local farmers on that particular piece?
Sure, yeah, and so I think there's a couple of different ways. I mean, certainly with regards to refining those management zones, I think some of it is going to be based on observations at the edge of the field. So obviously getting some more edge of field sites and monitoring programs in place. And some of it is also looking at a landscape analysis. So, you know, whether it could be some of the modelers or other specialists that can look at things like soil and climate and other things that are a little bit more specific about those regions. So I think it's a combination of the two.
Okay, so yes, I've just posted or opened the closing poll just to get a sense of how you perceive the information that was presented to you. It'd be great if you can fill that out. Any information can help. And if you are interested in working with us on the next steps, please get in touch with me. I have my email address in the poll. You can also add it in the chat box so that it's easy for you to copy and paste. If you have any questions or any other follow-up, we are happy to take those at this time. So I'll just give everyone a minute to finish the closing poll. But in the meantime, I will just say thank you so much to Merrin for this presentation. Thanks so much for gathering all of this information. I think it's a really interesting framework to look at next steps as well. And thank you very much to everyone who joined us today. It was really great that you could join us. And with that, I think we will end things. So thanks so much again. Have a great day, everybody.
Thank you.